Okay. Hello, alkene and alkenes. Last class we discussed about polyhaloalkanes. Polyhaloalkane compounds are over. Different type of polyhaloalkane compounds are there. One is dichloromethane, trichloromethane and tetrachloromethane iodoform, and last one is DDT. Para, that means para dichloro diphenyl trichloroethene. Ethane is known as DDT. DDT used as one of the household insecticide, and some other uses and some defects are there for polyhaloalkane compounds. And here now we are going to discuss almost lesson completed, but some questions are here. The questions today we will solve. First one, we are going to solve the question number 10.7. 10.7 in text question. First question is, which alkyl halide from the following pairs would you expect to react more rapidly by an SN2 reaction mechanism? Explain your answer. Here two questions are there. Total three questions are there. In first question, two options are there, and second question, two options, and third question also two options are there. In this, first one is identify the reaction mechanism of SN2 reaction mechanism. SN2 reaction mechanism. SN2 reaction mechanism को identify करना है. तो नीचे first example is CH3, CH2, CH2, CH2 and bromine, means bromobutane or butyl bromide. And other one is, in this other one, 2-bromobutane, CH3, CH2, CH3. This is known as 2-bromobutane. This is the first question. And second one is, first we are going to discuss what is the answer in this question. First question is to identify the SN2 reaction mechanism of following given compounds. First one is 1-bromobutane and second one is 2-bromobutane. Here first we know what about SN2 reaction mechanism. In SN2 reaction mechanism, there are two reactants will be participated in reaction. That means slow step. This slow step is known as RDS, rate determined step. In this rate determined steps, in case two reactants will be participated, then that reaction is known as SN2 reaction. Means if the rate of reaction depend on two reactants, that reaction is known as, otherwise that reaction belongs to SN2 reactions. Okay. Here first, which compound is follows SN2 reaction mechanism. In this one, first identify primary secondary carbons, then we will easily know the which compound can follow SN2 reaction mechanism. Here this carbon is primary carbon and here this carbon is secondary carbon, but we know the order of SN2 reaction mechanism and SN1 reaction mechanism. SN2 reaction mechanism order is primary is greater than, secondary is greater than tertiary. Then maximum primary haloalkanes shows SN2 reaction mechanism and tertiary SN1 reaction mechanism. After formation of carbocation, tertiary carbocation is more stable, that's why it will follows SN1 reaction mechanism. But here in primary haloalkane, there is primary carbocation will be obtained, only one electron pair donating group is there, it will be less stable, that's why compulsory other reactant will be react on primary carbon, then thus that reaction will be forward. That's why in these two examples, here the first compound 1-bromobutane is follows SM2 reaction mechanism into that order. This is the solution for first question. 10.7 में first question को complete हो. Next, second question is 2-bromobutane, like that one, CH3 CH2 CH3 bromine, and in this one other one tertiary butyl bromide CH3 and bromine. In these two compound, which compound can follow the SN2 reaction mechanism? Simple, follow the order. Primary is greater than secondary is greater than tertiary. In this one, this carbon is secondary carbon and this carbon is tertiary carbon. So in these two, tertiary is maximum more possible to follow the SN2 reaction, because here when the bromine will be removed as negative sign, then secondary carbon will get positive sign. Secondary carbon is less stable than tertiary carbon, that's why this will follow SN2 reaction mechanism in this example. And third example, here one of the important question, this one is, I will erase all the things on the board, then I will write third question. Order is similar, primary, secondary and tertiary. Here third example is third question is CH3 CH3 CH2 and bromine in this one. And second one are CH3 CH2 CH3 CH2 Br. This is the other example. Number of carbons are same and one substrate bromine similar. These two are the isomers because same molecular formula but structure is different. In this one, the nomenclature of this compound is 1, 2, 3, 4. Here bromine also substituent and methyl also substituent, that's why 1-bromo 3-methyl butane, and that one similar numbering 1, 2, 3, 4, 1-bromo 2-methyl butane. Right, in these two compounds, which compound can more follow SN2 reaction mechanism? In this one, first compound will follow more SN2 reaction mechanism. Why? Second compound will not. Reason, here methyl group is electron donating group. This electron donating group methyl is nearest to the halogen attached carbon. Here the electron donating group methyl is far from halogen attached carbon, क्योंकि यहाँ पे ब्रोमीन नेगेटिव साइन में रिलीज होगा तो कार्बन पे पॉजिटिव साइन रहेगा. दोनों में सेम, प्राइमरी कार्बन, दिस वन इज प्राइमरी, दिस वन आल्सो प्राइमरी. व्हेन ब्रोमीन इज रिमूव्ड एज नेगेटिव साइन, देन पॉजिटिव साइन विल gain on first carbon, then primary carbocation will be obtained. But here the electron donating group position will be different. In this compound, the first carbon having third position methyl group, and second carbon methyl group having on second carbon, that's why it is nearest to the carbon cation, then it will be more stable, and it is less stable than that one, that's why it is more ready to react in SN2 reaction mechanism. It is very important क्योंकि मिथाइल अल्काइल हाइलाइट अल्काइल ग्रुप जो कार्बन के साथ अटैच है वो कार्बन से कंपेयर करेंगे तो डोनेटिव ग्रुप मैक्सिमम डिस्टेंस पे है, और वहां पे हाइड्रोजन अटैच्ड कार्बन से कंपेयर करेंगे तो मिथाइल ग्रुप नियर पोजीशन में है, तो ये मोर स्टेबल रहेगा, लेस स्टेबल रहेगा. ऑल लेस स्टेबल कार्बोकेटन्स विल फॉलोस SN2 reaction mechanism. This is the solution of 10.7 in text question. And another question is there, 10.8. In the following pair of halogen compounds, which compound undergoes faster SN1 reaction? First question, we identified SN2 reaction mechanism, and second question is to identify the SN1 reaction mechanism given examples. First one, SN2 reaction mechanism, and 10.8 SN1 example. First example is carbon, right, and chlorine, and another one is chlorine, and second one is 1 2 3 4 5 6 7 1 2 3 4 5 1 2 3 4 5 6 7, and one position, this position having halogen, and another one is last 1 2 3 4 5 6. These are the compounds. From this compound, identify which compound can follow SN1 reaction mechanism. Already discussed SN1. SN1 order is reverse. Tertiary is greater than, secondary is greater than primary. उल्टा होगा. फर्स्ट क्वेश्चन का एक्सैक्ट उल्टा रहेगा. फर्स्ट क्वेश्चन पूरा क्या है? सेकेंडरी, दैट मीन्स SN2 रिएक्शन मैकेनिज्म को आइडेंटिफाई किया, इन दिस SN1 रिएक्शन मैकेनिज्म को आइडेंटिफाई करना. तो ऑर्डर इज वेरी इंपॉर्टेंट. Tertiary is greater than, secondary is greater than primary. That means carbocation. Tertiary carbocation is more stable than primary carbocation is more stable than, secondary carbocation is more stable than primary carbocation. Here, this compound, carbon having 4 bonds. This one is methyl, 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 otherwise compulsory methyl only, and chlorine. And here 1 2 3 4 5 1 2 3 4 5, and position is 1 2 3 3 chloropentane. In this one, this carbon is secondary carbon, and here this carbon is tertiary carbon. That's why this tertiary carbon containing haloalkane will follows SN1 reaction more than secondary. Means ये मैक्सिमम SN1 रिएक्शन में पार्टिसिपेट करने के लिए चांसेस है. तो दिस वन इज फॉलोस SN1 रिएक्शन बिकॉज दिस वन इज tertiary halide, right? And in this second question, here this one is secondary carbon, and halogen attached to this carbon is primary carbon. We know very well, compare only secondary and primary. Secondary is greater than primary, that's why this secondary carbocation is more stable than primary. That's why this one is follows more SN1 reaction mechanism comparison with 1 chloro 1 2 3 4 5 6 1 chlorohexane. मीन्स इससे कंपेयर करेंगे तो ये मैक्सिमम SN1 रिएक्शन में पार्टिसिपेट करेंगे, ये टेरिशरी SN1 रिएक्शन में पार्टिसिपेट करेंगे. ये क्वेश्चन नंबर 8, दैट मीन्स 10.8 लेसन नंबर 10, क्वेश्चन नंबर 8 in text question. And another one question is there, one of the very important regarding conversions, very important. It is based from chemical reactions, maybe preparation, maybe chemical properties. Here question number is 9, very important, because when you know the conversion of when you know the conversion of reactions. This is completely based on 11th organic reaction mechanism. If you know the preparation properties of haloalkanes very well, then we will convert it easily. Here the question is identify A, B, C, D, E and R and R dash in the following. Question number 10.9 in text. Identify A, B, C, D, E, R and R dash in the following. In the following. In the following. And the question is, it is cyclohexane. 1. This will react with magnesium in presence of dry ether. And what is the product formed at the place of A, and it will hydrolyze by water and forms compound B. And next, second question. Before going to second question, we'll discuss what about A and B products. First, here reaction is given. This compound react with magnesium in presence of dry ether. We know very well, when alkyl halide treated with metal, then organometallic compound will be obtained. This organometallic compound will be prepared by Grignard scientist in 1900. According to that reaction, the Grignard reagent is RMgX, alkyl magnesium halide. Here, this compound reacts with metal of magnesium in presence of dry ether. Here, in the place of A, magnesium and bromine, means alkyl magnesium bromide will be obtained. Here RMgX, when this RMgX hydrolyzed, means product of A is equals to this compound. And what about B? When this RMgX treated with water, that means hydrolyzed, then alkane will be obtained. Alkane means here the plain cyclohexane will be obtained and magnesium hydroxy bromide is byproduct. So cyclohexane will be obtained. Cyclohexane is equals to B. B is equals to cyclohexane and A is equals to cyclohexyl magnesium bromide. These are the product of A and this is product of B. And then C, D, E, R and R dash remaining are there. Here alkyl bromide treated with magnesium in presence of dry ether, and it will forms product C, and this C product on hydrolysis, that means deuterium oxide heavy water, then it forms CH3 D, means hydrogen isotope है D, hydrogen isotope ये deuterium oxide है, तो hydrogen isotope deuterium, तो deuterium यहाँ पे सेकेंड पोजीशन पे आया, तो वहाँ पे कंपाउंड C आइडेंटिफाई करना है. C आइडेंटिफाई करने से पहले फर्स्ट हियर व्हाट अबाउट R इज वेरी इंपॉर्टेंट. R कंपाउंड आइडेंटिफाई होगा तो यहाँ पे C आइडेंटिफाई होगा, उसके बाद वो प्रोडक्ट को हम लोग लिख सकते हैं. तो फर्स्ट व्हाट इज द group of alkyl compound. Then when we take here 2-bromopropane, CH3 CH3, 2-bromopropane, on reaction with magnesium in presence of dry ether, then C product is equals to C product here CH3 CH3 magnesium bromide, alkyl magnesium halide RMgX, and on reaction with deuterium oxide, then D will be substituted at the place of magnesium, that means second carbon, then CH3 CH3 D, and here Mg would be Br byproduct form. This is product of D. Already यहाँ पे जो है वही है, but C is equals to, this is not D, this is the product as is well given in textbook, and C product C is equals to this one, and R is equals to 2-bromopropane is R compound. R यहाँ पे क्या होगा 2-bromopropane R. तो यहाँ पे हम लोग को ये completed, B completed, C completed, and R also over. Next we are going to find what are the compounds of D, E and R dash. Okay, first I will erase all the things and then I will write another one on the board. Okay, right. Okay, next question is here R dash X, it is react, it will forms CH3 CH3 and in presence of sodium and dry ether, and next same thing is react with magnesium and forms D product. On this product D it will hydrolyze and forms E product. तो हम लोग ये प्रोडक्ट को आइडेंटिफाई करना है फर्स्ट थिंग, राइट. हियर फर्स्ट व्हाट इज द ग्रुप ऑफ R dash, ये important है. Here this reaction is similar property of Woods reaction. When haloalkane treated with sodium metal in presence of dry ether, then double carbon containing alkane will be obtained. Similarly, here this alkyl halide R dash is equals to CH3 and chlorine. टेरिशरी ब्यूटाइल क्लोराइड होगा तो ये प्रोडक्ट फॉर्म होने के चांसेस है. तो मैं यहाँ पे लिख रहा हूँ दिस वन इज 2 मोल्स ले लो in presence of sodium and dry ether. Woods reaction, मतलब double carbon containing product will be obtained. Sodium chloride is byproduct. Then similarly CH3 and another one 2 mole CH3 Cl in presence of sodium. यहाँ पे NaCl बाई प्रोडक्ट रिलीज होगा and then it will be attached to each other. Above compound will be obtained. That means this is the R dash product, and this is also over, and remaining two products are there. One is D and another one is E. When this alkali halide treated with magnesium similarly, तो यहाँ पे R dash is equals to ये कंपाउंड है, तो ये मैग्नीशियम के साथ रिएक्ट होगा, मैग्नीशियम के साथ रिएक्ट होगा तो अल्काइल मैग्नीशियम हाइलाइड ऑर्गेनोमेटालिक कंपाउंड फॉर्म होगा CH3 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 मैग्नीशियम क्लोराइड फॉर्म होगा ऑन हाइड्रोलाइसिस ऑफ दिस प्रोडक्ट, मतलब यहाँ पे D फॉर्म होगा. दिस इज द प्रोडक्ट ऑफ D. D is equals to CH3 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 and magnesium, means tertiary butyl magnesium chloride is the product of D. And when we hydrolyze this D, means D प्रोडक्ट को हाइड्रोलाइज करेंगे तो टर्शियरी ब्यूटाइल मैग्नीशियम क्लोराइड को हाइड्रोलाइज करेंगे तो CH3 CH3 CH3H ये फॉर्म होगा. दैट मीन्स 2-methyl propane is main product and second by product is magnesium hydroxy chloride is byproduct. So 2-methyl propane is the product of E. E is equals to 2-methyl propane. D over E over. These are the complete reactions and A, B, C, D, E, R and R dash. यहाँ पे R ग्रुप को आइडेंटिफाई करने के बाद C के बारे में आइडेंटिफाई कर सकते हैं, और R डैश होगा तो D E के बारे में हम लोग फाइंड आउट कर सकते हैं. These are the reactions like conversion reaction. If you know the preparation and chemical properties of haloalkanes, then we will convert the reaction easily and we can identify the product or reactant at the place of any A, B, C, D, E, F. अदरवाइज अल्काइल ग्रुप को आइडेंटिफाई कर सकते हैं, आर डैश अनदर अल्काइल ग्रुप को भी आइडेंटिफाई कर सकते हैं. दिस इज द आंसर फॉर क्वेश्चन नंबर 10.9. and remaining questions are there. If any questions you have doubt, you can ask on WhatsApp and any other electronic media. And some exercise questions are there. Starting questions are very easy. Nomenclature, identify the types of haloalkane, etc. are there. Next, some questions are there. That questions I will be explained afterwards. Next class we will discuss some more questions regarding this lesson, and day after tomorrow I will start another lesson. The another lesson is lesson number 11, alcohol, phenol and ethers. If you have any doubt, you can ask on WhatsApp and I will give notes of this lesson on WhatsApp only. Okay, right.